here, I've literally tried to simplify the notation again, and then we'll build it up to Bayes' theorem. But look, those who have an allergy, 1% of the population. I mean, and these kind of things are kind of known, I suppose, and 99% don't have the allergy. And then if you do, okay, cool, that has now saved. So let me go back. No, that's the movie. Ah, there we go. Okay. Hopefully you're back seeing my screen again. Somebody just shout out yes that you can see the nice little tree diagram with probabilities on.
Yeah, we can.
Yep.
Super. Thanks, guys. Okay. And look, this is the old way. Okay, so this is the grade 9, 10 GCSE way. What's the probability that I have the allergy given that I've tested positive, given yes, you know, given that the test says yes? And you can see that from the simple conditional probability formula, which I've got down here, which is here, then I'm going to just highlight the bits that I need to feed into the formula. So let's go for it. Equals P of A and Y. Well, look, the P of A and Y is a simple section on the tree diagram, isn't it? P of A and Y is just this bit, isn't it? I have the allergy and I've been tested positive. So that's that bit. And what's the probability that I get tested positive? What's the probability that of Y? Well, that bit is clearly on the diagram as well. It's this bit plus this bit here. Okay, so let's just put those numbers in the right place. On the top it's 0.008, and then that is divided by P of Y, and P of Y is the 0.008 plus the 0.099, and then you literally just crunch that in your calculator, don't you? Okay, but now if we think about it and start to put the Bayes' theorem formula together, we can. Yeah.
I had a question. For the numerator of the calculation you're doing now.
Yep.
Why isn't it P of A and Y times P of A?
Okay, so what I've done is I've gone back to the grade 9, 10 notation here, okay? The fuller notation isn't, well, the full notation I'll show you now. Let me add that on now because that's a good question. So let me get the pen back on. The full notation is this, that this 0.01 here is P of A, obviously. And this point A is actually P of Y given A, okay? So this 0.008 at the end in grade 9, 10 style, that would be has allergy and is tested positive, okay? But the actual notation would be, and I'll adjust this now for Bayes' theorem, the actual notation here would clearly be P of A times by P of Y given A. So can you see we've moved, haven't we, from that grade 9, 10 notation into our grade 11 notation? So that, yeah, really good question there. And so let's update the denominator as well. You know, we've seen from the tree diagram how to get the numbers at the end of the branches and then chuck them into the right place. But now let's kind of delete this bottom bit here, because this bottom bit isn't just P of Y, but the P of Y comes from this top branch here and also this branch here. And can you see the top branch is obviously P of A times by P of yes given A plus this branch here. Okay, and this branch is P of not A times by P of yes given not A. And there you have it. There you have Bayes' theorem written out in all its glory and splendor. Okay, and this is why that, you know, even mathematicians at our level, our HL level, we kind of love a diagram to help us unpack what the formula means and which numbers go in the right place. So certainly for 2 events, I'm a big fan of still using the diagram. But when we move beyond 2 events, going to a 3rd event, then there may be some benefits to using Bayes' theorem. Okay, I'm going to press